Welcome Dr. P. Seville, Professor in the Department of Mechanical Engineering at SA Engineering College. Dr. Seville has many achievements. He leads ongoing government projects worth around rupees 82 lakhs from DST. He completed project worth around rupees 47 lakhs from DST, state government and TNACST. He has 11 Indian design patents granted, 6 published and 4 filed for new products. Under his guidance, 8 research scholars completed PhD and 8 more are working on at Anna University. He got funded from DRDO, SIR, and also organized 3 national workshops, 1 international conference. He published 72 research papers, which are included in 34 in SCI and 38 in Scopus reputed journals. He presents at over 43 conferences. His Scopus index, H index is 19 with 1366 citation. He wrote 6 books and 2 book chapters from foreign publications like German. He won awards like Best Researchers in 2020, Best Academic Professional 2024 from IE India, Best Scientist Award in 2021 and 22 academic year, and Mission 10X Excellence in Teaching. Today he shared his research knowledge on research scope in selective laser melting for automotive and aerospace. Please give big welcome to Dr. Seville, sir. Thank you, sir.
Very sincerely thank Dr. V. Muthukumar and Dr. Kadambi Srinivasan for providing a valuable opportunity to present this today's session on the topic research scopes in selective laser melting with respect to automotive and aerospace sectors. Sir, shall we start, sir?
Yes, sir.
Okay, sir. So my screen is visible, sir?
Yes, sir. Visible, sir.
Okay, sir.
Stop sharing my screen, sir. You can share your own screen.
It is visible in 3D printing, is visible. Am I right, sir?
Yes, sir. Clearly visible, sir.
So, very good morning to all the participants, especially faculty members, research scholars, professors from various universities and engineering colleges. So, I take immense pleasure in presenting this session. And as you see this today's session, the topic is selective laser melting. So, before going on to selective laser melting, I want to give you a very small and short introduction about 3D printing. As you know that 3D printing is nothing but 3-dimensional thing. So, this one is going to be very basic. So, a 1-dimensional object is going to be a line. As you can see, it is going to be a 1-dimensional object.
Students, please be muted. Speaker has to have an attention.
Sir, shall I proceed, sir?
One second. Instruct. Sir, everybody make sure you are muted. Speaker has started his speech. So it is to make.
Shall I continue, sir?
Yes, sir. Please continue, sir. If
okay,
it
okay. Thank you, sir. So, 2-dimensional object is going to be square and rectangle. Now, moving on to 3-dimensional object, any object which is going to have length, height, and width, it is going to be called as a 3-dimensional object. So, traditionally, you are printing on A4 sheet like this. Here, the thickness is going to be negligible, so it can be called as a 2-dimensional printing, as you can see over here. So, this one is going to be 2D printers on the left-hand side, but on the right-hand side, you can see the latest type of the printers, which is going to be called as your 3D printers. So, what do you mean by the term 3D printing? In very local terms, it is going to be called as 3D printing, but technologically, we are going to call it as additive manufacturing. So, if you are going to see this additive manufacturing, it is not going to have any machining process. In simple words, it is opposite to subtractive machining. In subtractive manufacturing or subtractive machining process, you are going to remove the material from the given specimen and you are going to convert it into the required shape and size. But in the alternative, in additive manufacturing, you are going to construct a three-dimensional object. So a three-dimensional object is going to be constructed based on the CAD model which is going to be given to the three-dimensional printing machine. That is, you are going to have a 3D printing machine. It may work on the technology of FDM or laser metal deposition or solid laser melting or solid laser sintering. So whatever may be the working principle of that machine, the machine is going to be connected to a software, and in that software you are going to develop a digitalized 3D model. A three-dimensional structure of that model is going to be generated in the software, and whatever structure is going to be present in that software is going to be presented in the form of. So it is going to be presented in the form of a three-dimensional object. So we are going to develop a 3D printing in which material is going to be, in which you are going to see that a computer-controlled machine is going to print the objects in three-dimensional form. That is going to be called as a three-dimensional printing. And here you are going to print the material layer by layer.
Dr. Seville, sir, your slide is not changing to the next number. Hello. It keeps on in the same place, sir.
Okay, I will
First
again,
slide. Please reshare the screen, sir. It will be corrected.
Sir, now you can see the screen, sir.
Yes, sir, I can see, sir, but it is in the first slide number, sir. Your affiliation slide is there, sir.
Yes, sir.
Now it is changing, sir. Thank you, sir. Sir?
Sir, now the screen is visible, sir.
Yes, sir. Now your slides are
Slides are
visible,
changing,
sir.
sir.
You can continue, sir. Thank you, sir. Yes, sir. Now it is changing, sir.
Okay, sir. Okay, sir.
Thank you so much, sir.
Now you can see 2D versus 3D printing. Now I want to show you a small miniature of how the Eiffel Tower is going to be printed directly. I will be showing a short video. This is going to give you a glimpse of how about the 3D printing is going to be printed. Here I think you can see the video. So now if you see this screen, the printer is going to be a very basic model, and this printer is going to print a Eiffel Tower in 3 dimensions. Normally, if you are going to print the Eiffel Tower on a A4 sheet of paper, it is going to be called as a 2 dimension. But here you are going to see the 3D printing of a Eiffel Tower. You can see over here. And if you see here the printing does not occur entirely, it is going to occur step by step. In better words, technically, layer by layer printing is going to take place, as you can see over here. So the entire 3-dimensional structure is presented in a layer by layer manner, as you can see over here.
Dr. Seville, sir.
Yes, sir.
Sir, your voice not audible, sir. Now it is okay.
My voice is not audible.
Now it is audible, sir. Before it was very silent. That's why I asked you, sir.
Voice audible இருக்குங்களா இப்போ?
இப்போ கரெக்டா இருக்குங்க சார்.
Okay, I am just sharing the video.
Okay, sir. Okay.
So now you can see a 3-dimensionally printed Eiffel Tower miniature. This is nothing but a 3-dimensional way in which metal is going to be printed layer by layer. Here you can see a PLA or ABS printed specimen. PLA or ABS is nothing but a plastic material. So if you are going for plastic or polymer, normally they will be going for nylon, or they will be going for PLA, or they will be going for ABS. So this is going to be very basic steps in 3D printing. So to give you a small idea how the 3D printing is going to take place, I shared this video. Now moving on to the next thing, how the 3D printing is going to work. What is going to be the basic working principle? The basic working principle started with FDM. So FDM stands for Fused Deposition Modeling. As you can see over here, I think the slide is visible. So the basic and one of the preliminary working principle of 3-dimensional model was based on FDM, that is Fused Deposition Modeling. If you are going to see this, here there is going to be a machine. That machine is nothing but a 3-dimensional printing machine, that is a 3D printing machine. which is going to deposit the filament of a particular material. It may be ABS, or it may be plastic, or it may be Kevlar, or it may be nylon, or it may be any type of the thermoplastic material or any other plastics. And layer by layer it is going to deposit that filament, and one over the other, layer by layer, a metal is going to be generated, and a binding or a bonding is going to be generated by means of heat or adhesion. And the plastics are the material which is going to be printed, which is going to be deposited layer by layer, is going to be in the semi-liquid state, and it will be returning to its original solid state after some cooling period. So if you want to see this, this is going to be the working principle, the photographic view which illustrates the working principle of fused deposition modeling. So I am moving my arrow here. I think the screen will be visible. Here you can see a material spool. This is nothing but the raw material which is going to be fed into the built material or built platform over which the three-dimensional object is going to be constructed. So if you want to print a material made out of ABS or PLA or nylon or Kevlar or any other type of the plastic, the material spool is going to be built out of that material, or it is going to be fabricated out of that material. Here you can see the material spool. Then it is going to be fed into the nozzle. Before the nozzle, the entire material spool, that is the wire spool, is going to pass over a heating element. In this heating element, what will happen? The solid wire, which is going to be in the solid form, is going to be heated to a specific temperature, so that it converts into semi-liquid state. More or less in the molten state is going to take place. And when it comes out of the nozzle, it is going to be in semi-liquid state, and it is going to be deposited on the built platform. Here you can see the built platform. It is going to be deposited on that. And here you can see the nozzle is capable of moving in transverse direction. That is, it can move left, it can move right, it can move front, it can move back. And even it can move up and down. So three-dimensional movements are going to be possible. Horizontal, vertical, and longitudinal is going to be possible over here. So it can move left, it can move right, it can move up and down. So everything is going to be there. So this is nothing but. So if you want to see animation, here you can see the animation, how the fused deposition model is going to be printed over here. Here you can see the animation over here, how the object is going to be printed in a three-dimensional manner using this fused deposition modeling. So here you can see this screen, as you can see over here very clearly. Here you can see. My screen is visible. So here you can see the three-dimensional object which is going to be printed using this fused deposition modeling process. Here you can see the wire spool, as you can see over here. Here you can see the wire spool over here, and it is going to be printing in a continuous manner, layer by layer. Here on the right hand side you can see a teacup which is going to be generated, and on the left hand side you can see an object which is going to be printed layer by layer. So this is going to be about the basic working principle. So I am again showing a detailed, elaborated schematic view of the fused deposition modeling process over here. So here you can see the support filament, a three-dimensional view rather than a single view. It is going to be called as a three-dimensional view, in which you can see the support filament, the built material filament, the extrusion heads, how the support filament or the built material filament is being pulled by the drive rollers, and how it is being sent out of the extrusion nozzles. And you can see the built platform, and over that you can see the foam base, and out of which the parts are going to be built over here. So here you can see two different materials. One is going to be the spool for the built material, another is going to be for the support material, as you can see over here. Now I am sharing a video which will be giving a detailed idea about the fused deposition modeling. Please see this video.
Is a layer hydrogen. This technology is going to reduce the detail. Weight ratio. FDM is ideal for concept, functional prototypes, manufacturing aids, low volume. The FDM process begins by slicing the data off the layer. The data is then transferred to a machine, layer by layer on a real platform. These red light screws are thermoplastic or material are used to create each section of the part. Similar to a hot dog movement, uncoiled material is slowly extruded.
So you can see here you can see the various materials. On the left hand side you can see the support material spool, and on the right hand side you can see the build material spool, and you can see the extrusion nozzles, and you can see the liquefiers, and you can see the dry wheels. And what the dry wheels are going to do now, they are going to rotate in clockwise, anti-clockwise direction and clockwise direction opposite manners, and they are going to feed the support material as well as the build material into their respective liquefiers. The liquefier, what is going to happen? Both the built material as well as the support material are heated to a specific temperature such that they get converted into a liquid, semi-liquid state. So at this state, what is going to happen? The extrusion nozzle is going to extrude them outside, and they are going to be deposited layer by layer. Now you are going to see whatever I have narrated in the form of the video. Please watch this. Now you can see the printed specimen, and they are taking it out of the
parts that this is the layer on. Further, service providers install content offering multi-position service parts. FDM is utilized in a number of industries, including aerospace, automotive, and medical.
As it has been narrated in this video, you can see that this fused deposition modeling process is used in variety of industrial sectors, including aerospace and automobile sectors. So this is going to be again a slide showing that. Now moving on to the additive printing working principle in detailed manner. You can see the step-by-step procedure, which is you can see in the additive process. First, you can see a print. You can see the three-dimensional CAD model on the left-hand side of the screen, which is going to be the first step. Then it is going to be fed to the printer. From the software, it is going to be transferred to the machine, and the machine is going to exactly print the three-dimensional structure using any one principle like FDM or SLM or LMD or any other type of the printing process. And on the right hand side, you can see a three-dimensionally printed structure. This is going to be a very simple step. If you want to see the elaborate step, you are going to have totally 7 steps. Step 1, you are going to generate a 3D model using a computer-aided design software, that is a CAD software. Like your Kriya, or you can generate software using CATIA or ProE, etc. You can generate a 3-dimensional computer-aided design model, and it is going to be converted into STL format, because STL format is going to be one of the suitable file format which has been exclusively developed for 3-dimensional printing machines in the year 1987 itself. And STL format stands for Standard Tessellation Language. So whatever going to be your CAD drawing, whether it is going to be drawn in AutoCAD or ProE or CATIA or Unigraphics or whatever going to be software, it is going to be converted into STL format. Then this STL file format is transferred to the additive manufacturing machine. That is going to be the step 3, in which the STL file is going to be manipulated, and in the 4th step, the machine is going to have its own requirements, and after the refilling the polymers, the binders and the consumables, etc., the printer is going to about to start. You can see here in this slide, if you are going to see, you can see a generated CAD model which is used for additive printing. And in the fifth step, the three-dimensional structure is going to be printed, and depending upon the size and dimension of the object, the machine and the materials being used, the process duration is going to take hours or even days to complete. And the sixth step is going to be removing the printed three-dimensional object from the machine. And third step is going to be post-processing. It includes bathing or removing the unwanted additional structures, etc., so that the entire or complete three-dimensional structure is going to be fabricated or is going to be obtained. And now I am giving you a summary of all these steps. So 3D CAD model is going to be the first step. Then second step, you can see a STL file. Then a slicing software is going to be used. The slicing software is going to read and manipulate the STL file format, and it is going to print layer by layer. And the slices you can see over here, and a three-dimensional object is going to be printed, as you can see in this slide. So if you are going to see this below, you can see the human face. And if you see the third slicing software, you are going to see a photograph in which it is going to have some built support structures. Support structures is going to be there, so that the entire structure is going to be supported and the object is going to be printed. Then applications of 3D printing machine you can see over here. So this is going to be the various applications. Now I am going to, rather than speaking about the applications, I am going to share you a video which will be giving a detailed view about the various applications of 3D printing.
This is Industry Wednesday. Every Wednesday is a different history. Today we're looking at 15 about the 3D group. Come to A.com to click Billionaires Assumption. Have a look at students. It's time to have a look at the blockchain, not the electric car. The 3D printing we must even destruct the world as we know it. Since the 1980s, technology has evolved a lot. One has $200. First, we need to know how to read and applications throughout the entire process, which is unlike pretty much anything.
Sir, Dr. Selvil, sir.
Yes, sir.
Are you sharing any video, sir, right now?
Sir?
Video window is not visible, sir.
Yes, sir. Video I am sharing, sir. You do not see that?
No, sir. If you can share your entire screen, it will be good, sir. Entire screen.
Okay, sir.
Stop the sharing and share your entire screening, sir.
I am sharing it again, sir. I think you
Yes,
can see the video now. Is it clear, sir?
Now it is okay, sir.
Okay, sir. Okay, sir.
Thank you, sir.
So this video gives you a complete idea about the 3D printing industry, and it is going to share you some recent advancements which has happened in the 3D printing industry and which has revolutionized various industrial sectors. So please watch this video.
All four goods, bowls, pots, holders, and anything. Then work with. Of course, you can also start. If you're new here, welcome. And follow us on EMATS'25. But if you'd like to learn some more about the focus on large sales and other costs related, just sit back and relax, because we have all four of them. You can very expensive. All every really big construction work is a depending on the object it could be sold for about $30. Number two, all planes who have 3D printed. We all know that things are full metal flying objects must do so by the electrical model. So there's the limit. In this case, the sky's the limit. Literally, more planes are now comprised of a 3D printed piece. But don't worry, they use titanium, not plastic. This really if they would say, oh, after $300, The entire airline industry will benefit big time from 3D printing, and this is only the beginning. New industries will adopt 3D printers and robots as well. They are the future. Number 3. Swedish luxury sports car Polestar has 3D printed components in their car. If you're not a luxury sports car fan, you may not know the Swedish brand Polestar, but it's one of the most beautiful, fast, and limited edition cars in the world. The company was born a little over 20 years ago. They only make around 15 cars per year. Of course, it's all manually done and handcrafted with state-of-the-art technology because these beauties are sold for over $2 million each. Although the concept only has a few 3D printed pieces, there is a car called Urban that has the body and the windows printed. Number 4. The world of medicine will benefit the most out of this technology. Next on the 3D printing list is humans. Until then, technology has evolved so much that nowadays a few small things can be printed and then used for medical purposes on humans. This new discovery will help newborn babies and donors to find the knowledge. So far, medical 3D printing can do the following: tissue with blood vessels, drugs, prosthetics, bones, heart valves, symbolic skin, and organs. As you can imagine, these breakthrough printed supplies are currently being tested on animals, and if all goes well, we'll be printing anything in no time. Number 5.
So if you have seen this video, they are showing I think now it is visible. They are showing the three major sectors. One is going to be aerospace, another is going to be automotive, and another is going to be medical. Apart from this, it is going to be used in fashion and retail, defense, even in printing of the drones, then architectural structures, games or entertainment purpose, etc. But the three major areas which the 3D printing is gaining attraction and it is of more vital importance and which is going to have a bloom in the coming years is going to be automotive sectors, aerospace sectors, and medical implants. Not only medical implants, even any organ can be dimensionally printed using this 3D printing technology. So you can see some of the automotive components on the right hand side of the screen and aerospace components which are going to be printed using this 3D technology. Here you can see the automobile parts which are being 3D printed, and here you can see some of the medical implants which are being 3D printed using this technology. So this is going to be a summary of these technologies. Now, before moving on to selective laser melting, what are all the various types of the additive manufacturing technologies which are going to be available? So, based on the working principle, it is going to be categorized into 6 different types. First, if you are going to extrude the material, it is going to be called as your fusion deposition modeling or fused filament metal fabrication. That is FFM or FDM. So, the initial process in which using which we printed the 3D material was FDM. And here you can see the metal extrusion processes. It is going to be categorized into 2 divisions. One is going to be the old and traditional fused deposition modeling FDM, and another is going to be fused filament fabrication methodology FFM. Next, if you are going to print the material using a wet photopolymerization technique, it is going to be called as your selective laser, that is SLA or DLP. And if it is going to be a powder bed fusion methodology, then it is going to be called as your selective laser melting, that is SLM, or selective laser sintering, or direct metal laser sintering process DMLS, or EBM. So it is going to be a 4 process. So out of which we are going to see about SLM in detailed manner today. So SLM is going to be a powder bed fusion type of the 3D printing technology. And if you are going to deposit the energy directly, it is going to be called as your laser metal deposition, that is LMD. And you are going to have EBAM, and if you are going to be a material jetting process, it is going to be MLM, and sheet lamination, it is going to be laminated object manufacturing or UC. So before moving on to SLM, that is selective laser melting, I want to give you a difference between the powder bed fusion and direct energy deposition. Now I am going to share a video about LMD. So I will be sharing the screen again so that you can see the video clearly. So this is going to be the video which elaborates about the laser metal deposition process. Here you can see the direct energy deposition. So metal is being deposited in a direct manner using the form of the nozzle. As you can see over here, this is laser metal deposition. The laser is going to be used for depositing the material onto the surface of the built platform or the substrate, as you can see over here, and metal is built at layer by layer. And on the right hand side, you can see the time which is going to be running out. So up to now, as of now, it is going to be your object which is going to be printed using this. And you can see here the base plate, the platform which is going to carry the base plate is capable of moving in multiple directions, X, Y, then front and back, up and down, etc. And you can see a structure is going to be printed. As you can see a structure is going to be getting printed out, and it is going to be three-dimensional structure. This is going to be your direct energy deposition process, which is going to be called as a laser metal deposition. This is also a 3D printing process, or it is also a additive manufacturing process, but it is completely different from selective laser melting. There you are going to use a powder bed fusion technology, but here you are going to use a laser metal deposition, as you can see over here. I want to show you the final shape. This is the shape which is going to be printed. So you can see the final shape which is being printed. It is going to be like a pot-like structure, but it is going to be fabricated out of here metal. So it is going to be a metallic pot. This is laser metal deposition. So now moving on to the slide again. Now moving on to selective laser melting. As I already told you, it is a powder bed fusion process, and it was invented, or it was developed in the year 1995 at INT, that is Forward Institute for Laser Technology in Germany, and it was patented in the name of Dr. Dieter and Dr. Matthias, who are associates of INT research team. And if you are moving on to the selective laser melting process, here you are going to have a bed which is going to be full of metallic powder, out of which I want to fabricate the structure. So if I want to fabricate a structure out of aluminum, the bed is going to have aluminum powder. Or if I am going to fabricate a structure out of titanium, it is going to have a titanium bed. It is going to be of titanium structure, as you can see over here. I will be showing a video which will be explaining you clearly how this laser beam melting is going, selective laser melting is going to work. So I will be sharing the screen again, so that you will be getting the video clearly. Please see this video. If you are going to see this video, it is going to be give you a detailed process about this selective laser melting and how it is going to work. So here basically the principle is going to using the process of heat. Heat is going to be used for melting the metal powders. And you are going to have a perfect precision in the part which is going to be 3D printed, and you are going to print the material layer by layer. As you can see over here, it is going to be a layer by layer printed structure. So you can see this, you will be getting a clear idea. You can see a laser beam which is going to pass onto a laser bed, which is going to be fed completely with metallic powder, and layer by layer at specific parts the laser beam is going to melt that metallic powders, and a joint is going to be formed when melting is going to take place one over the other. Now you can see this, how it is going to happen. So if you can see this, this is going to be the built material. The entire built layer is going to be filled up with the aluminum powder or titanium powder or stainless steel powder, as you can see over here. And a laser beam which is going to travel at particular travel velocity, that is going to be called as your scanning speed. And the laser power is going to be emitted at 500 watts or 600 watts or 700 watts, etc., based on the metal capability. And this laser beam is going to melt the metallic powders, and the laser beam is going to fall on some particular specific place, and when it is going to fall on that specific place, the metallic powder present on that place will get melted, and when the layer by layer melting is going to take place, the 3-dimensional structure is going to be attained. So that is going to be the working principle of selective laser melting. So in simple words, we are going to see that the selective laser melting is going to use a high power laser, and it is going to be a laser powder bed fusion process in which the metal powders are going to be fused one over the other using the heat which is going to be generated from the laser beam. So if you want, I can share you a very clear video which is going to show you how these 3D structures are going to be printed. So this is the structure I want to print. Say for example, this is the structure I want to print. And here you can see the exact structure which is going to be printed over here. Now for printing this 3-dimensional structure using selective laser melting, and I am going to follow this procedure. So first I am going to orient the angle at which the object must be printed. So the object cannot be printed as it is in space. It requires some support. It must lie down on the substrate at some particular orientation or at a particular angle. For that, I need some support structures. So I am going to define the support structures first. This is going to be the working principle of selective laser melting. I define once again. If I want to print a 3-dimensional structure, I want to define the orientation, or I want to specify the angle at which the object must be printed. So if I am going to put it at some particular angle, the object cannot lie in space. It needs some supports. It must lie down on some support structures. For that, I am defining the support structures as you can see in this video. Now you can see that. You can see this is going to be support structures which you can see, which is going to be built out of the support material, which is going to be very thin when compared with the base material or when compared with the built material. Because I am going to break the support structures after printing the 3D structure. So the support structures is going to be unwanted thing after fabrication of the entire structure or entire specimen. So for breaking it in a easier manner, it must be brittle and it must be weaker when compared with your built structure. So if I am going to fabricate in batches, you can see over here I am placing at various angles. Now I am going to start the process. So here you can see an exact realistic view or realistic photograph of a selective laser melting machine, as you can see over here. Now they are going to print the same structure which you have seen few seconds before using this machine. So this is going to be the entire platform which is going to carry the metal powders. You can see it. Now layer by layer powder is being fed on that. So if you can see here, we have the intensity of laser beam which is being used for melting this particular powder, metal powder. It may be aluminum or it may be inconel or it may be titanium. It is going to be 500 watts. And it is traveling at a speed of 1 meters per second, as you can see over here. So in 1 second it is traveling at a speed of 1 meter. So here deposition takes place. So laser beam has melted particular portion, as you can see over here. And now after the printing process is completed, here you can see the 3-dimensional structure being fabricated. Now you can see the entire structure which got fabricated, and the remaining powder has been completely recovered. Nearly 99% of the powder had been recovered, as you can see over here. So this is the entire printed specimen, but you can see additionally it is having support structures. Those structures are going to be removed, as you can see over here. Now we are going to remove the support material. Very simple, because they are going to be very light. They are going to be of minimum strength, and they are being removed from that. After that, we are going to do the sandblasting process, so that the unwanted materials sticking onto the surface of the printed specimen are being removed. And you are checking for the dimension, as you can see over here. That is, validation process is being carried out. So now you can see the entire 3D printed specimen using this selective laser melting. So if you can see this in this particular part, so you can see the laser beam being falling onto the metal powder bed, and particular portion, this laser beam is going to transfer the heat onto the powder, metallic powder. Metallic powder will get melted over one over the other, and the fusion is going to take place. So I will be closing this video. So I think we have got some clear idea about the selective laser melting. So whatever thing you have seen, now you can see it in the form of a three-dimensional view, as you can see over here. Now, moving on to the parameters. So if you want to, with respect to the research scope in selective laser melting, in India, we are having selective laser melting in Bangalore and in Chennai. In Chennai, you are having the selective laser melting process in some private industries. And if you are going to see what are the parameters which can be varied, you are having a lot of parameters which can be varied here. You can see first what is going to be the intensity of the laser and what type of laser you are going to use, and what is going to be the scanning speed of that laser at which it is going to be do the scanning process. Then what is going to be the strategy you are going to follow for scanning that laser beam, and what is going to be the edge spacing left out. This is going to be the laser relevant properties, and the spot size which is going to be generated by this laser beam. So totally you are having 6 parameters which can be varied with respect to laser alone. This area is going to be better suitable for optimization process, so that you can vary the optimization process, and you can use some advanced software, AI based, ML based building softwares for optimizing these parameters. And with respect to the powder bed, you are going to have some parameters. First, the deposition strategy. How the metal powders are deposited over there, what strategy you are going to follow, and what is going to be the depth of the each and every layer, and what is going to be the density of that particular metal powder bed, and what is it's going to be its temperature, and how this building chamber atmosphere is going to be maintained. What type of gas you are going to use inside the building chamber, that is going to also play a very important role. Apart from these two properties, that is laser related properties and powder bed related properties, you are going to have the powder related properties, that is with respect to metal properties. So what is going to be the material, whether it is going to be aluminum, or it is going to be titanium, or it is going to be inconel, or it is going to be stainless steel. And what is the size of the particle, and what is going to be its form, and how this particle is going to have this flowability, and what is the density of the powder. All these parameter combinations, if you see, nearly you are going to have minimum 15 to 18 process parameters which are going to play a very important role or crucial role in determining the quality of the parts which are being printed using selective laser melting. So advantages, if you are going to see the advantages, it is a very accurate process which is going to print a perfect accurate structure with very quality precision. And what are all the type of materials which can be printed using selective laser melting? It is going to be very vast. You can print aluminum, you can print inconel, you can print stainless steel, even titanium can be printed, even magnesium can be printed, copper can be printed using this selective laser melting. And it can create even advanced complicated structures which is going to have intricate shape and dimension can be fabricated very easily using this selective laser melting process. And the parts which are going to be fabricated using a selective laser melting are going to be fabricated at a very faster rate when compared with other 3D printing process, and it reduces the delay times. So these are going to be the advantages of the selective laser melting. Next, what are all going to be the drawbacks? So if you are going to see the drawbacks, you need extensive support structures. That is going to be one of the most important requirement. For support structures alone, you have to spend some amount, and you need a specific type of inert gas for maintaining the atmosphere inside the selective laser melting printing environment. And it is going to be a high energy process, so it is going to have some stress, and dislocation of the parts are going to be possible, and they are going to have some compromise in the structural integrity which is going to be of the fabricated parts. And the surface which is going to be generated out of the selective laser melting, or normally they are going to have a rough surface, and you need some post-processing techniques to be carried out to make it perfectly have a perfect surface finish. These are all going to be drawbacks. Despite its drawbacks, selective laser melting machine is going to have a wide variety of applications in automobile sectors, aerospace sectors, in medical, especially with dental and medical engineering equipments, implants, prostheses, etc. It is going to have a lot of applications. Then It is going to have used in fabrication of various types of the production tool inserts, as you can see over here. Then, what are all the types of the materials which are being fabricated using selective laser melting? I already told you, you can fabricate copper, you can fabricate aluminum, stainless steel, inconel, nickel-based superalloys, cobalt, tungsten, and even titanium. And the tungsten parts which are being fabricated, especially in selective melting temperature, are going to be very famous in the automobile sectors. And you can fabricate various materials like 15.5 stainless steel, 17.4 stainless steel, mar-raging steels, cobalt chromium, especially titanium alloy, Ti6Al4V, etc. using this process. So this is going to be about the selective laser melting which is being fabricated. Now, moving on to the various research scopes in selective laser melting. As you can see over here, I have given you an elaborate diagram which shows you what are all the various types of components which can be fabricated using selective laser melting, so that they are going to be used in automobile sectors. First, the fluid handling parts, especially the pumps and valves, can be printed using selective laser melting. And what type of metal they are going to use? They are going to use aluminum alloy. So the aluminum alloys which are going to be used in the pumps and valves of the automobile sector, which is used for handling the fluids, they can be printed using selective laser melting. And the exterior parts, that is bumpers and windbreakers, can be fabricated using selective laser melting, as well as using selective laser sintering process. And the powertrain and the drivetrain, that is the engine related components, can be fabricated using selective laser melting, and they are usually fabricated using fabricated out of aluminum and titanium alloys, as you can see over here. Then even the entire frame of the automotive panels, the body structures, the doors can be fabricated using this selective laser melting process, and they are made out of aluminum alloys. And the OME components, that is the body in white structures, can also be fabricated using this SLM, and they are usually made out of aluminum and steel alloys. And if you are going to see this another thing, especially the suspension systems, they can be fabricated using selective laser melting as well as using selective laser sintering. And the suspension systems and tires are fabricated out of polymers and aluminum alloys. So they can be produced using selective laser melting. So using selective laser melting, you can fabricate both metals as well as polymers. Non-metallic structures can also be fabricated. And you are going to have the exhaust emissions, which is going to have aluminum alloys as their raw material. It is going to be used in cooling vents. So this and all is going to be the applications with respect to automobile sector. And you can see the process, that is your raw material is going to be in the powder form, and you are going to subject it to selective laser melting. And as I already told you, selective laser melting is going to need a lot of post-processing process, and the automobile parts are going to be fabricated, as you can see in this slide. Next, you can see some of the automobile components which are fabricated using this selective laser melting process. So ICC, Intelligent Cruise Control Radars. You would have heard about this ICC, which is going to be used in the recent type of the automobiles, which stands for Intelligent Cruise Control. So those radar mounting brackets and the bumper prototypes are fabricated using this selective laser melting. And moving on to automotive sector, we are also having wide applications in aerospace sectors. So the major structural seat components with respect to aerospace sectors are fabricated using this selective laser melting process. You can see the armrest, you can see the seat leg assembly, you can see the baggage bar, you can see the spreader bars, even the seat back frames, the back pan, the armrest, the cross tube, everything are being fabricated out of the selective laser metallic printed three-dimensional structures. So the armrest structure, the back pan, the seat back frame structures, which are fabricated using this, are used in aerospace structures. And I don't want to limit my presentation with automotive and aerospace sectors alone. Another scope is going to be available even for mechanical engineer, because lot of biomedical components are also fabricated using this selective laser melting process. And if you are going to see this, what are all the components which are being printed and what is going to be the advantage, you are going to have a wide variety of design freedom in designing these components. The cost is going to be very much minimal when compared with traditional, and it is going to be, the parts are going to be fabricated in time, and the quality is going to perfectly meet the requirement, and you can validate the entire design by prototype itself, and it is going to be an environmental friendly process. So I want to share a paper which is going to be, which are printed titanium especially for dental applications. Now I'm going to show that video so that you'll be getting a clear idea how the structure is going to be printed. It is going to be a dental structure. So you can see the dental structure which is being printed using this dirty laser melting process. So you can see some of the structures which are being printed using this dirty laser melting process. You can see the laser beam is being passed on to the bed, which is going to carry the entire metal powders, and layer by layer the laser beam is going to melt those metal powders, and another powder layer is going to be fed onto that. So layer by layer melting of the metal powder is going to take place, and finally you are going to take the specimen out, as you can see over here. This shows you the realistic view of the entire 3D printing machine, as you can see over here, and they are collecting the entire powder back. Nearly 90% of the powder is going to be collected back, and now they are taking the fabricated specimen out of the substrate, that is out of the building plate. You can see over here. So this is going to be a printing of structures in mass production, which is going to be in batches, which is going to take place. So like this, they have built a, instead of creating all dental implants, they have created a spider web like structure dental implants, which is going to have some enhanced quality and enhanced performance when compared with the traditional type of the dental implants. So this is going to be one of the area. So the areas where you can concentrate is that you can concentrate on fabricating the solid laser melting parts by varying the parameters. Say for example, you can have the common layer thickness is going to be 20 to 50 microns. Here you can vary the thickness, and you can vary what are all the parameters you can vary. You can vary the type of the laser which you are going to use, and what is going to be the scanning rate, what is going to be the scanning speed at which the parts are going to be printed. Even you can vary the axis spacing distance and scanning strategy. So with respect to laser, the four things which are going to be normally used in the papers is going to be, what is going to be the intensity of the laser, that is the power, laser power, then scanning speed, mm per second, then axis spacing distance in microns or in mm, then scanning strategy, in what orientation you are going to build the entire thing. Then with respect to powder bed related properties, you can vary the building chamber atmosphere, what type of gas you are going to use, and what is going to be the depth of the layer, particle layer, that is powder depth layer is you can be vary, you can vary. And with respect to the powder related properties, what type of materials you can vary is that you can vary the size of the particle and you can vary the density of the powder. So these two parameters are going to play a very important role. So here we are having nearly a combination of nearly some 8 different parameters which can be varied by using Takuchi or by using response surface methodology or by using advanced AI based fabrication techniques and machine learning based techniques. You can vary the entire process, as you can see over here. So this is going to be the various factors which can be considered in solid laser melting. So a wide variety of parts and prototypes are being fabricated, and what are the type of the material you can print? As I already told you can print using aluminum, stainless steel can be printed, then titanium can be printed. So normally go for titanium or tungsten or nickel based alloys, and even inconel can be printed. So already many people have started their work in aluminum. So you can go for titanium or stainless steel or nickel based alloys, or you can go for inconel. These are the materials which are having more chances of converting into a paper and getting accepted. So with this, my presentation comes to an end. So I very sincerely thank the program organizers, Dr. Muthukumar sir and Dr. Kanamdas Srinivasan, for providing an valuable opportunity to deliver this session. Thank you.
Sir. Sir, myself Aravind, sir. Please 1 minute, sir. Muthukumar, sir, will join shortly, sir.
Okay, okay, sir. Okay.
And Kanaka, sir, also will come, sir.
I will.
1 minute, sir. 1 minute, sir. Participants, if there is any question, please post in the message box so that professor can ask accordingly.
If you are having any questions, sir, please post the messages. I will give the reply immediately.
Sir, personally, I have a question
Yes, sir, please
about
tell me,
suggestion for journal, sir.
Yes, sir.
We are working on a polymer-based composite material, sir.
Okay,
Like
sir.
HG, PETG, PLA, ABS and all, we are working on it, sir. We need to know the suitable journal for the short publication process, sir.
Journal.
Yes, sir.
Okay, sir. You are having a journal in progress in additive manufacturing, sir. That journal is having a decision within some 5 days. They'll be giving the
Right.
first decision whether the paper is suitable for journal or not. So, progress in additive manufacturing, you can go for that, sir. That is going to be a very good journal, which is having impact factor of 5.3 with respect
Okay,
to
sir.
3D printing process. You can
Okay,
choose
sir.
that one, sir. And apart from that, you are having journal of materials engineering and performance.
Okay, material engineering and performance.
Journal of materials engineering and performance. It is going to be a Springer journal,
Okay, sir.
which will be maximum. The acceptance rate is going to be nearly some 75%, sir. So,
Okay,
if you are
sir.
having some different concept like 3D printing, always the paper welcomes such type of the thing.
Okay, sir.
Already I have published more than some 7 papers in the journal itself. So it is a good quality journal and it is going to have a reasonable review time, sir. And reviews will be normally reasonable. Maximum, they will try to give some reasonable comments. Even though you will be receiving the comments from more than 5 reviewers, it will be in a
Okay, sir.
reasonable manner and you will be
Okay.
having some sufficient time
Okay.
to
To respond.
send your waste paper. And apart from that, within some say for example, if you are going to submit that paper within 1 month, you will be receiving the review comments, sir.
Very good, sir.
There are
Okay,
many
sir.
journals. You don't know what is happening for the nearly 6 months or 7 months. After that, you'll be receiving a comment that the paper is restricted, non-fitting norms, etc.
Yes,
But
sir.
those type of journals can come back with these type of journals: progress in additive manufacturing, journal of materials engineering performance. All these things are very good quality journals which are having a good acceptance rate with respect to 3D printing, sir.
But the acceptance rate is more than 60%, sir.
Yes, sir. Acceptance rate is more than 60% for journal of materials engineering performance, sir.
Okay,
And
sir.
it is giving preference for 3D printed materials, especially. Even though it is not exactly related to journal of materials engineering performance, is not directly related to 3D printing. But nowadays, in the last 4 years, many 3D printed papers, if you see, if you go for the journal and if you see the list of published papers in the last 3 years, nearly some 40 to 50% of papers related to 3D printing are you can see.
Okay, sir. Okay, sir. Thank you for your
Impact factor is going to be around some, I think it will become surrounding some 3, sir. 3.2 or 3.2 something. It is a
Okay,
very
sir.
good journal. American Society of Mechanical Engineers, ASME. It's
Okay,
also
sir.
a part of the journal. It comes for Springer, sir.
Springer. Okay, sir.
Yes,
Okay,
sir.
sir. Thank you for your valuable
You can also try progress in additive manufacturing. Within some 5
Progress
days,
in-
they'll be telling whether it is suitable for journal or not.
Okay, sir. Okay. We are working on polymers only, sir. Thermoplastic polymers, sir. So we are planning, sir.
இல்ல சார் தெர்மோபிளாஸ்டிக் பாலிமர்ஸ் தான் நான் ஸ்பெசிஃபிக்காவே சொல்லிட்டு இருக்கேன். ஈவன் மெட்டலுக்கு வந்து பாத்தீங்கன்னா இந்த ஜர்னல் இஸ் கோயிங் வெரி மச் சூட்டபிள். பட் லாஸ்டா வந்து பாத்தீங்கன்னா தெர்மோபிளாஸ்டிக் தெர்மோசெட்டிங் பாலிமர்ஸ் பிளாஸ்டிக்ஸ் எல்லாத்தையுமே 3D பிரிண்ட் பண்ணதுல இந்த ஜர்னல் வந்து பாத்தீங்கன்னா நியர்லி சம் 40% பேப்பர்ஸ் ஆர் ரிலேட்டட் டு திஸ் பிரிண்டிங் ஆஃப் திஸ் பிளாஸ்டிக் ஸ்ட்ரக்சர்ஸ். நீங்க போய் ஜர்னல் ஆஃப் மெட்டீரியல்ஸ் இன்ஜினியரிங் பர்ஃபார்மன்ஸ் நெட்ல போட்டுட்டு list of papers published in the recent years பாத்தீங்கன்னா you can see many type of the 3D printing papers can be available in that journal.
Okay,
So
sir.
அந்த ஜர்னல்ல பாத்தீங்கன்னா you can get some idea what are all the papers, what are all the areas in which they have worked out. So you can get some idea. That also
Okay, sir. Thank you for your reply, sir.
Thank you, sir. Thank you, sir. Any other query, sir?
Dr. Muthukumar, sir.
Yes, sir. Available, sir. Any other question from the participant? You may please type in the chat box or put your voice question itself. One question is there in the chat box, sir.
Madam has asked about wire arc additive manufacturing. Madam, when wire arc additive manufacturing is a traditional 3D printing process, madam. So when compared to selective laser melting or laser metal deposition, wire arc additive manufacturing is having some inferior features. So when you are going for 3D printing, always go for selective laser melting or fused filament fabrication or laser metal deposition. Or you go for even serial lithography, or even you can go for laminate object manufacturing. But wire arc additive manufacturing, the parameters are most relevant to electronic type of parameters. So it will be suitable for EC scholars. But as a mechanical engineers, if you go for wire arc additive manufacturing, the parameters which are varying is in the form of the electronic signals and electronic intensities. So you will be having some waveforms and you have some wave signals. which cannot be easily understood by mechanical engineering team. So you have to some struggle will be there. So my suggestion are normally go for this type of the mechanical relevant 3D printing process, so that you are having wide variety of parameters which can be varied. Say for example, in laser metal deposition or in solid laser melting, you can vary the powder intensity, laser beam intensity, powder particle size, the ash spacing, the orientation, everything can be varied, so that a lot of scope is there for optimization. Even you can metallurgically, நீங்க மெட்டலர்ஜியா பிரிண்ட் பண்ணி நீங்க பாத்தீங்கன்னா கூட அந்த ஸ்ட்ரக்சர் வந்து ஒரு ஆங்கிளுக்கும் ஒரு டிஃபரெண்ட் ஸ்ட்ரக்சர் உள்ள இருக்கும். இன்பிட்வீன்ல மேக்ரோ மைக்ரோல டிஃபரன்ஸ் தெரியும். ஸோ செமி இமேஜ் போனீங்கன்னா இந்த ஒண்டர்ஃபுல் ஸ்ட்ரக்சர்ஸ் வந்து விசிபிளா இருக்கும். அது மெட்டலா இருந்தாலும் சரி, பிளாஸ்டிக்கா இருந்தாலும் சரி. ஸோ கோ ஃபார் திஸ் டைப் ஆஃப் தி பிரிண்டிங். திஸ் இஸ் மை கைண்ட் சஜஷன், மேடம். Please don't mistake. Thank you.
Sir, regarding sustainability factors, sir, while doing 3D printing,
Yes, sir.
and especially any additive manufacturing, what kind of measures researchers, particularly those who are pursuing doctoral research, to keep in mind?
If you want to speak frankly, sir, machines are available mainly in Bangalore only, sir. So with respect to Chennai, you are having machines in chiplet, but in chiplet normally they will not be varying the parameters, sir. So parameters will be a constant thing. So even if you are going to print 10 cubes, or if you are going to print 10 flat plates, or you are going to print 10 specimens, macro, some will be showing the same image if you are going for that. So there will not be any use in printing 10 specimens with the same parameter combination. So there you can print a structure, but it is not having any parameter combination. Different parameters cannot be possible, sir. So you have to go for Bangalore. In Bangalore, Wipro, DRDO labs, they are having this type of this laser melting, laser metal deposition, sir. So very simple, sir. If you want to complete a research scholar work in with respect to 3D printing technology, identify a suitable company in Bangalore, sir. You just put in Google 3D printing companies in Bangalore. Lot of companies will be coming over there. So in that company, fabricate a small cube, which is going to be even of 10 mm cross 10 mm cross 10 mm size. So fabricate some 10 or 11 cubes. Put a Daguchi or orthogonal array in a paper, and you show the variation with respect to the parameter combination in a micro, macro, semi image. You don't need to even go for tensile in semi image fractures. Just a cube, what is its macro, micro, and the semi observation, and you just apply some 11 cubes, a Daguchi orthogonal array, even 9 samples. It will be converted into a paper, sir. Like that only I am converting some papers, sir, because the cost of printing, no, sir, especially metal components, is very high. Even on cube goes around some 8,000, sir. So plastics, if you are going for it, goes around some 3,000 or some 4,000. So 10 specimen, it will come around some 40,000 rupees, etc. So plan accordingly. And if even what is the unique feature of 3D printing? Nowadays, 3D printing papers are getting absolutely very easily if you include a small optimization technique. You don't need to go for any AI like RSM. Even without RSM, a simple N9 orthogonal array. You are going for that. Because nowadays 3D printing is in evolving stage only in India, especially with respect to Tamil Nadu. Many people are going for 3D printing of the metal structures, plastic structures alone. So if you are going for printing of metallic structures and with some simple orthogonal array, the paper chances are getting accepted is going to be very easy. This is my kind suggestion, and this is my experience.
With respect to participants here, you have any questions? Any more questions? Okay, sir. In that manner, I would like to ask one last question, sir.
Sure, sir.
Pertaining to this topic of this particular FDP, sustainability factors in 3D printing. What people can keep in mind for sustainability, sir?
That is, you are meaning SDG goals.
Somewhat, sir. Yes, for reducing waste, zero carbon, something like that.
But actually, if you are going for SDG goals, means here it is going to have wastage is going to be very much minimal, sir. In additive manufacturing itself, you are going to completely minimize the wastage because it is going to be additive process rather than a subtractive process. In subtractive process, what you are going to do, you are going to remove the entire machining process, you are going to do the machining, and you are going to remove the material from the given specimen. But here, material removal is not going to take place. Here, material wastage is going to be completely eliminated, and compared to the subtractive process, nearly some 87 to 99% of the material is going to be saved. If you have seen my videos, sir, whatever powder they are going to use for this, the entire powder is going to be recovered back after the solid laser melting process. So powder wastage is going to be very, very minimal in 0.05%. So 99.95% of the powder is going to be recovered back after the process. So here material wastage is going to be completely minimal. And the post cleaning process, if you are going to see that, it is going to be very costly with respect to solid laser melting, but very minimal with respect to laser metal deposition. So the post cleaning is going to be reasonable, and it is completely ready with perfect surface finish and accuracy. So the SDG goals, one of the goals is going to be, we are living in the era in which we are always aiming towards minimizing metal wastage. So here minimal metal wastage is always going to be very, very minimal, and you can recover the entire metallic powder after the process, and the metal powder can be used again and again and again and again for any number of times of printing the same component. This is going to be unique feature with respect to sustainability, sir. 3D printing itself is a sustainable process.
Okay, sir. Okay, sir. So why we asked that question is we are taking the session after session, different topics, sir.
Okay.
Your session is very unique, sir. Particularly, you are the person who took an 3D printing perspective, and you selected selective laser melting and even laser melting.
Yes, sir.
Whatever topic related to metal 3D printing, you completely covered, sir. This will be much more useful for our scholars.
My suggestion is that, sir, nowadays everyone is going for 3D printing and trying to convert their paper, but everyone is focusing towards plastics. Nowadays, now a few seconds also, one professor, I think Arvind Rajas, I asked a question related to thermoplastics.
Okay.
My suggestion, if he is working on, if he is planning to shift towards metal, his paper will get accepted immediately, sir. So my suggestion always try to go towards printing of metallic structures, because metallic structures in South India is very rare. And if you find out industry in Bangalore, and if you are ready to spend around some 50,000 rupees, you can fabricate structures, and it can be coupled with a minimum optimal array like artificial techniques, and it can be converted to a paper. That will be giving you a lot of inputs for getting a paper accepted immediately. So try to go for this type of the techniques. Previously, I was working on friction stir welding, but nowadays friction stir welding got exhausted. So I have moved towards the 3D printing technology, especially metallic parts. Because even in schools nowadays, 3D printing of polymers, plastics, PLA, ABS is available. So school students will also be aware of 3D printing of plastics. So more research scope is not going to be there, and you have to write a elaborate detail, and you have to do a lot of research work with respect to plastics. But with respect to metal, the opportunity is very minimum, and the industries which are printing, for example, sir, a 3D printer, metal printer costs around some 2 to 3 lakhs. Sorry, 2 to 3 crores. So it is not affordable for a self-financing engineering college, so you have to go only for industry. So your industry collaboration will also improve, and you can in NAC or NBA, etc., you can show that industry collaboration, and in your paper you can collaborate industry. So that if I already mentioned with the coordinator, that we are also having some collaboration with foreign countries, so they are printing the structures, and we are including them as co-authors. When you are going to input them as co-authors in your paper, what will happen? The citation will also improve. Not only your citation, in your NAC or NBA, you can show that you are having a collaboration with foreign expert people, foreign professors. So it will be what I can say, it is going to be a multinational collaboration. It will be bringing merits for your NARF ranking, NAC, NBA, and at the same time, when you are going to fabricate some structure with the foreign process, you can accomplish at a very reasonable cost. Like this, many chances are going to be there. So it will be improving your profile as well as your rank, as well as your merit in the department also, sir. So please concentrate towards R&D with respect to metallic parts of 3D printing structures.
Okay. For the participants, those who want to contact the speaker, details are available with me. Sir, with your permission, may I share your phone number and email ID?
My request, if you want to connect me, please kindly connect me through WhatsApp messages.
Yes, sir. Yes, sir.
So I will, please don't make phone call to me, because everyone will are working in self-financing college, you will be in a meeting or in a classroom. So my kind request, always contact me through WhatsApp by posting your name and what is the purpose of message. I will always send WhatsApp reply message within 2 to 3 hours. I will always reply to any WhatsApp message coming to me.
Okay, sir. Okay, sir. So in case they ask your number, I will give your WhatsApp number.
Surely, sir. You can give it, sir.
So
My request are there. Please tell them to contact me through WhatsApp message.
Yes, sir. Yes, sir. I understand. So we will come to a conclusion, sir.
Okay, sir.
There are no more questions, sir. So it is my duty to thank you to committing to the schedule. In fact, I have asked you to come for a different time also. You have stick to your words. You have given a very wonderful picturesque.
I am grateful to the organizing team.
Yes,
I also sincerely thank you and Dr. Ganavas, especially the head of the department of Mechanical Engineering and the entire management of Tech Meditech for providing an opportunity to present this session. I very sincerely thank the entire organizing team behind this FDP program. It is a very good initiative.
Yes,
nowadays, as an organizer, I also know how much difficult it is going to coordinate the various session speakers and to make them to come in the time and to ensure that the session is going on, mic is on, all the participants have been muted, and the session goes on smoothly for the 1 hour. And many problems are there, sir. I also recently conducted a AIC response at FDP. I know each and every struggle behind that. So it is going to be teamwork. More than that, the HOD, especially the conveners, Dr. Muthukumar and Ganapati Srinivasan and the entire organization team behind that, and the management, principal of Meditech, Meditech, etc. I very sincerely thank all of them, and I also admire towards your entire, what I can say, splendid work for organizing FDP in spite of your busy schedule, because in private engineering college you will be always equipped with some sort of work. So in spite of all the schedule, you are aiming towards conducting some useful sessions like this FDP. So my hats off dedication, my hats off to the entire team, sir.
Thank you very much, sir. Thank you, sir. Thank you, sir.
Thank you.
So, speaker may leave, sir. Thank you very much, sir.
Thank you. I am leaving, sir.
Participant, yes, sir. Thank you, sir.
Thanks a lot.
Thank you very much, sir. Participant, please stay in the meeting, sir. Participant, there will be a link for your feedback. It will be shared as usual in the afternoon session. We are not sharing in the morning session. So, thanks for your patient listening. Much of the people who are over here, Dr. Rajesh Khanna in the meeting, Dr. Mohan Kumar, everyone is known to me actually. Commitment to attend the meeting by the other department people like chemistry is also very well welcome. My only request is to interact by question. And if you have not listened to this in live manner, there is a YouTube recording available. So kindly make use of it. The meeting will go on for another 1 or 2 minutes and we will close the meeting. Thank you. Thank you very much.